Hello students, welcome to my maths class once again. So in the last class I have done up to question number 6 of exercise 13a of chapter number 13, okay, and today I shall start from question number 7. So the question is, in the diagram of the following figures, name the triangle which is congruent to triangle ABC, keeping the letters in the right order. State the congruence condition also. That means we have to compare with the triangle ABC. In every triangle, in every figure, there is a triangle ABC, okay. Then you have to compare that with triangle ABC, which triangle is congruent, okay. So as we have already discussed in the previous question, what is congruent, okay. So a triangle becomes what congruent when three parts of this particular triangle is equal to the other triangle. Then you can say that these two triangles are what? Congruent. And one thing we know before that, okay, I shall discuss it later. Now you see, here you see in the first question, you see ABC is a triangle, okay, and here XYC is also a triangle, okay. Now we have to see with triangle ABC, which triangle is what? Which triangle is congruent? So first you see ABC in this triangle, okay. If I consider like this, if I draw separately, okay, then A, B, C, and this one will be what? Like this, okay, X, Y, and C, okay. So if you see here, you see AB, you see AC and XC, both are what? Equally. For this symbol you can understand that these two sides are equal, okay, and these two sides are equal. This symbol says that first this side and this side equal, this side and this side are what? Equal, okay. So you can say that AC of the triangle ABC and XC of the triangle XYC are equal. That means what? AB and what? XC are equal, okay. Now let us check. You see this BC of the triangle, BC of the triangle and what? YC, YC of the triangle are what? Equal, okay. And we can say that since they intersect at C, since AY and BX intersect at C, so when two lines intersect, then the vertically opposite angle forms. Then you can say that ACB and XCY, what? ACB and XCY are what? Equal. Angle ACB equal to angle XCY, okay. These two triangles will be equal, but we shall write these things in the next question. But here in this question it is said that name the triangle which is congruent, okay, and we have to name the triangle and state the congruence condition. Now to see the congruence what? Condition. Here we will not write the statements and the reason, just we will write the name of the triangle and the condition, with which condition they are what? Congruent, okay. So first you see, so you can say that these two triangles are what? Congruent, because one side is there, two sides are there, and one angle is there. So two sides, one angle. So you can say SAS condition, okay. So right there for triangle ABC, congruent symbol like this. If this is the congruent symbol, okay. Triangle ABC congruent to triangle XYC, triangle XYC, okay. By which condition? SAS, okay, by SS condition. Means one side, two sides and one angle, two sides, one angle. Okay, now come to question number B. You see triangle ABC, okay, and BQC, BQS. So from this we can say that AB and BQ are equal, because from the symbol you can understand AB and BQ are equal. If I take ABC one triangle and BQC one triangle, then you can say AB of the triangle ABC and BQ of the triangle what? BQS are equal. Okay, then this angle, you see, angle Q and angle B are equal. You see, these two are equal. Okay, and angle B and angle A are equal. That means what? Two angles one side. Two angles one side. You can say what? ASA, angle side angle. Okay, angle side angle, angle side angle. Okay, so you can say that what? Angle side angle. So ABC congruent to BQS. So the second will be what? Triangle ABC congruent to triangle BQ, triangle BQS. In which condition? ASA. This is the condition. Okay, this is the condition. Now come to question number 3. Okay, you see, this is very easy. These sides and these sides are equal. If I take ABC as one triangle and ADC as another triangle, so you can say that, you see, AB and AD will be equal. Okay, AB and AD will be equal from the symbol. Okay, and ACD 90 degree. Okay, and ACB, this angle is also what? 90 degree. So this angle and this angle are equal. Okay, and one thing another more is that, you see, when we are taking the name ABC, then AB, BC and AC is also one side. And when we will take the name of triangle ADC, then this side is also coming. That means what? AD, CD and SC. Okay, that means SC is the common side. Okay, you see, first if I draw a triangle like this, okay, if I break this triangle, okay, then it will be like this, A, B, C. Okay, and this will be what? Like this. Okay, A, D, C. Okay, if I break this triangle, then these two triangles will be what? Formed. Now you see, from the triangle, you see SC in both the triangle, SC is there. In both the triangle, SC side is there. So you can say that SC is common to the both triangle. SC is common to the both triangle. That means SC equals to what? SC. Okay, you see, SC, SC, in both triangle we are getting SC. So SC is what? Common side of this particular two triangles. Okay, so SC is what? Common. Okay, now you see, now you can say that AB, here AB equals to what? AD. Okay, and what? This angle ACD equals to what? ACB, and SC is what? SC equals to what? SC, because in both the triangles SC is a common side. So the three conditions are maintained. So you can say that what? They are congruent. How? You see, two sides AB and AD and SC, two sides and one angle. So you can, and one angle is what? 90 degree. And we have earlier read also that when two sides and one angle are 90 degree, then we apply the condition RHS, right angle hypotenuse side. Okay, so we can say that ABC, okay, we can say that ABC, triangle ABC congruent to triangle ADC. Okay, which condition? RHS. Okay, now you see, in question number 4, It's very easy in question number 4. You see, this side and this side are equal. If I talk about triangle ABC, okay, triangle ABC and ABC and ATB or ABT, then we can say that what? ABT, then or BAT, then you can say that what? You see, this side and this side are equal. That means you can say in triangle ABC, AC, and in triangle BAT, BT are what? Equal. You can write AC equals to what? BT. BT. And what? BC. BC equals to what? AT. Okay. And again like this, AB is the common side. Okay. AB is the common side. That means in both the cases we are getting side, side, side. SC and BT are side, BC and AT are side, AB and AB also what? Side. So we are getting what? Side, side, side. So we can say that triangle ABC congruent to triangle BAT, in which condition? SSS. Okay. In SSS condition they are what? Congruent. Okay. They are what? Congruent. ABC and APC, okay. So ABC, if I break this two triangle, then this side and this side are equal, okay, and AC is the common side of APC triangle and ABC triangle, and these two angles are equal, okay. So you can say that what? Two side, this side and this side, okay, and one angle. That means what? SAS. So I can say that triangle ABC congruent to triangle APC, okay, triangle APC, okay, triangle APC, in which condition? SAS. Why SAS? One side AB and AP, and AC is the common side, and these two angles, okay. Now come to this question. Here you see ABC, okay. Let me check the figure. ABC, okay, ABC, ARC, ABC and ARC. If I take two triangle, then let us check whether they are congruent or not. Yes, we can say they are congruent because you see angle B and angle R are what? Equal, and this side what? BC and RC are what? Equal. Angle B and angle R are equal, each 90 degree, okay, and angle BC of what? Side BC, okay, side BC and side RC are equal. From the symbol you see, it is in the given in the question that BC and RC are what? Equal. Now you see AC is the common side. AC in triangle ABC will get what? AC. In triangle ARC also will get what? Side AC. So you can say that they are congruent by what? RHS, because one angle is 90 degree, okay. So triangle ABC congruent to triangle what? ARC. Triangle ARC in RHS condition, okay, a right hypotenuse side, okay. Now come to question number 8. In each of the following, names the congruent triangles and state the congruence condition. As like question number 7, you see question number 8 is like this, okay. So you see in the following, you see the first one in the following figures. You see the first one, A, B, C and D, E, F. You see, you just look at your book, you can see that ABC and DEF. You see, in in the two triangles, the three sides are equal. So ABC, what congruent to? ABC congruent to what? ABC congruent to EDF by SAS. Okay. So the first one you see, first one is like this, A, okay, the triangle is like this, A, B, C and D, E, F. Okay, you see the question, this side and this side are equal. Okay, this side and this side is equal, and this side and this side are what equal? First side, second side, third side. So we can say that triangle ABC congruent to triangle DEF by SAS. Okay, by not SAS, by SSS, because here three sides are equal. Okay, SSS. Okay, DEF or EDF, anything you can write. Okay, now come to question number 2. You see, okay, triangle ABC congruent to triangle EDF. How? You see, this angle and this angle are what equal? Angle A equals to angle D. Okay, and this side. Okay, sorry, this side. Okay, so you see, AC and DF are what equal? So we got what? One angle, one side. Again you see, angle C and angle F are equal. So two angle, one side we got. So you can say that what? They are equal. So triangle ABC, okay, congruent to triangle EDF. Okay, by what? ASA, because two angles, 1, 2. Okay, two angles, 1, 2 angles and one side. Okay, now come to question number 3. You see, question number 3, this side and this sides are equal, this side and this side is equal, this angle and this angle is equal. Okay, so if I take angle ADB, okay, triangle ADB congruent to triangle what? ADB will be congruent to triangle BEA. Okay, if I take this triangle ADB, this triangle, okay, this triangle ADB B, and BED, BEA, then they are congruent. How? You see, this side and this side are equal. Okay, this side and this side are equal. This angle and this angle are equal. So we can say that what? Two sides, one angle. Two sides, one angle. That means what? SAS. Okay. Now come to question number 4. Triangle ADB will be congruent to triangle CDB. ADB, this triangle will be congruent to what? CDB. Triangle ADB will be congruent to triangle CDB. CDB, okay? CDB or CDB or CBD also we can write. CBD will be alphabetically, okay? CBD, okay? You see the sides. How? ADB, in this case you see this side and this side are equal, okay? And this angle, okay? This angle and this angle are equal. You see both the angles are equal. And what? BD is the what? Common side. ADB and B and CBD, that means BD is the common side. So you can say that SAS, two sides and one angle, okay? Another angle is also what? Congruent. You can see DAB, this triangle DAB congruent to what? BCD. DAB will be congruent to BCD. This angle and this angle are equal, okay? BCD, okay? DAB will be congruent to BCD. Why? With two angles, okay? This angle and this angle are equal, okay? DAB, this angle and this angle are what? Equal. This angle and this angle are equal. And DAB and what? BCD, DAB and BCD, DC and AB are what? Equal. So one side and two angles, so SAS, okay? Now come to question number 5. You see question number 5. Like this, the question number A, E, D, C, F, B, okay? This angle and this angle are equal. This side and this side equal. This angle and this angle are what? Equal. So you can say that triangle ADE congruent to triangle BCF. How you see? Angle D and angle C are equal. Okay. ED and CF are equal. You see, ED and CF are equal. And angle CFB, this angle 90 degree, and DEA, this angle 90 degree. So we got two angles on one side. Okay. So ASA. Okay. Now come to question number 6. Okay. You see question number 6, a triangle is given like this. Okay, A, D, E and B, okay, C, all names are given. You see, this angle and this angle are equal. Okay, this side and this side are equal. Okay, it is given in the question, this angle equal, this side and this side are equal, and this side. Okay, so you see, I can say triangle ADB, this triangle ADB will be congruent to triangle ADE, will be congruent to DEB. How? You see, in triangle ADE, AD and EB are equal. Okay, and angle D and angle E are equal. In angle ADB, angle D is equal to angle in triangle DEB, angle E is also equal. That means angle D and angle E are equal. Okay, and in both the triangle, you see, this side is common. ADE, D is coming. Okay, and whenever you take DEB, then D is also again coming. That means what? D is common side. So that means what? Two sides and one angle. Two sides, one angle. SAS. Okay. So now come to question number 12. High order thinking skills. Okay. You see question number 12. High order thinking skill. You see the diagram is given like this. ABCDE is a regular pentagon. Show that triangle ABC congruent to triangle AED. Okay, so let us draw first. A, B, C, D, E. Okay. Here you see, we have to show the triangle ABC. This triangle and this triangle are what? Congruent. Triangle ABC is congruent to triangle AED. Okay, AED. So how to prove? You see, write AB equals to AE. How? AB equals to AE. How? Since you see ABCD is a regular pentagon, and in a regular pentagon all the sides are equal. That means AB, BC, CD, AE, DE, AE, all sides are equal because it's a regular pentagon. So you can write sides of a regular sides of a regular pentagon. PNTAGON, sides of a regular pentagon. And you can say that AB equals to A. Okay, so right here from triangle, okay, we are comparing two triangles, from triangle ABC, from triangle ABC and AED, we have, then after you write AB equals to A. Okay, you write this line. Okay, from triangle ABC and AED, AB equals to AE. Okay, that means AB equals to AE from these two triangles. And you can say BC equals to D. BC equals to what? BC equals to D. Same reason. Okay, same reason, you write same reason, sides of a regular pentagon. And you see ABC, angle ABC equals to angle AED, angle AED. Okay, okay, here you cite angles of a regular pentagon are equal. Angles of a regular pentagon are equal. Okay, angles of a regular pentagon are what? Equal. When a regular pentagon will be formed, then their angles will be also what? Equal. So we can say angle B equals to angle E. So you can write ABC equals to AED. So we got two sides, one angle. So it's sufficient to say that these two triangles are what? Congruent. So therefore triangle ABC congruent to triangle AED. In which condition? Two sides, one angle. So side angle side. Okay, that is the answer. Now come to exercise 13B. Okay, you see in exercise 13B, AB and CD bisect each other at K. AB and BC bisect each other what? At K. Prove that AC equals to what? BD. Now you have to prove AC equals to what? BD. Okay, so check. First you draw the diagram. Okay, exercise 13B. Okay, question number 1, you see okay, here you see the question, it is given AB and CD bisect. Bisect means what? Equally bisect each other. AB and CD bisect means what? Bisect at K, each other at K. Prove that AC equals to what? BD. Now you have to prove AC equals to what? BD. Okay, so you see, before doing that I have to say one thing. Okay, you will find CPCT. Okay, so what is CPCT? Okay, CPCT means corresponding parts of a congruent triangle. Corresponding parts of congruent triangle. Corresponding parts of congruent triangle. Corresponding parts of congruent triangle. That means what you see, we will apply here. Okay. That means typicity means if the two triangles are equal. That means what? Congruent. Then we can say that the rest of the parts are also what? Congruent. Okay. We are showing two triangles congruent in three conditions. Okay. If the three parts of a triangle, if the three parts of two triangles are equal, then we are what? Saying that they are congruent, and the rest, and the typicity says that if the two triangles are congruent, then the rest parts also are what? Congruent. For that, corresponding parts of congruent triangles are what? Also equal. Okay. So you see here, you see I can write AK equals to BK because since they bisect each other. Okay. So I can write AK. Right, first from the triangle, from triangle AKC and triangle DKB, I can write what? AK equals to KB, AK equals to what? BK. Okay. And CK equals to DK, CK equals to DK because what? They intersect each other. Because you write since AB and CD bisect each other at K. Okay, you write this one. Okay, since AB and CD bisect each other at K, that means AB and CD bisect each other at K. That means this part and this part will be equal, this part and this part will be what? Equal. So two sides we have got. Now we have to find one side or one angle. Okay, so whenever these two line segment will intersect, then this angle and this angle will be what? Equal, because they are what? Vertically opposite angle. So we can write angle AKC equals to angle DKC. You write vertically opposite angle, you write fully vertically. Vertically opposite angle. Okay, vertically opposite angle, vertically opposite angle. Okay, now you see two sides and one angle are equal, so we can say that both the triangles are equal. Therefore triangle AKC congruent to triangle DKB, okay, DKB, okay, DKB. How they are congruent? Two sides, SAS, two sides and one angle. Now we can say that, you see, since both the triangle are what? Congruent, then the rest part also congruent. We can say that AC equals to BD. Okay, we can say that this angle and this angle and this angle will be equal, this angle and this angle will be equal, because the two triangles are equal. Then the rest parts, whatever remain, rest parts, rest sides and rest angles will be what? Equal. So we can say that AC equals to BD, because AKC we have taken the triangle, then AC is one part, and DKB we have taken triangle, then DB is what? BD is also one part of this triangle. So since the two angles are congruent, then this side, these two sides will be what? Equal. So we can write AC equals to what? BD. Here you write CPCT. If you don't write CPCT, then it will become wrong. Okay, CPCT. AC equals to BD, CPCT. Okay, proved. Okay. Now come to question number 2. The sides BA and CA have been produced such that BA equals to AD and CA equals to what? BA equals to AD and CA equals to AE. Prove that DE and DE parallel BC. Okay. So you see the second question. The second question is given like this. You first draw the figure, okay? Okay, A, B, C, E, D. Okay, this side and this side are equal. This side and this side are equal. Okay, it is given in the question. Here you see the sides BA and CA have been produced. That means side BA, sides BA have been produced to D and CA have been produced to E. It is given in the question. Such that BA equals to AD. BA equals to AD. That means BA is produced to AD in such a way that this portion BD and AD are what? Equal. And AC and ED are what? AC and AE are what? Equal. Prove that DE parallel BC. DE parallel BC. We have to prove that this line segment and this line segment are what? Parallel. Okay. So you see how we shall prove they are parallel. First you take from triangle ABC and triangle AED. What you can write? AB and AD are what? Equal. AB equals to AD, okay, and AC equals to AE. AC equals to AE. Both are what? Given. It is given in the question. You write given, okay, given. And I can say that BAC, this angle, and EAD, this angle will be what? Equal. Vertically opposite angle, because they intersect. When two lines segments intersect, then vertically opposite angle forms. Okay, so you can write angle BAC equals to angle EAD. Okay, vertically opposite angle. You write fully. I am writing BOA, that means vertically opposite angle, but you write fully vertically by spelling. Okay, so you can say that triangle ABC, what? Triangle ABC congruent to triangle AED. Okay, triangle AED. In whose condition? SAS, two sides. Okay, so if these two triangles are equal, then you can say that BC equals to ED. So you can write what? BC equals to what? ED. As like earlier, BC equals to what? ED. As like earlier, CPCT. Okay, BC equals to ED. We can write AED, this angle AED. Okay, AED equals to this angle ACB. How? They are what? Alternate angle. They are alternate angle. Okay, and you can say that you first you write here. Okay, first you write AED equals to ACB CPCT, because as we have said that when the two triangles are equal, then their rest corresponding parts are what? Equal. So this angle and this angle will be what? Equal. Okay, CPCT. And also we can write alternate angle. Okay, and we know that when two alternate angles are equal, then the side remaining with this angle are what? Parallel. That means we can say that if this angle and this angle are equal, then this side and this side are what? Parallel. Therefore we can write what? Angle BC, BC or DE parallel what? BC. Okay, proved. Since they are alternate angle. Okay, DE parallel BC. Now come to question number 3. You see the figure. OA equals to OB, OC equals to OD, AOB equals to COD. Prove that S equals to BD. That means AC and BD, the small parts we have to prove that they are what? Equal. So first we will take AOC as one triangle and BOD as one triangle. And if you can prove these two triangles are congruent, so we will say that SC and BD are what? Rest of the congruent part. So we can say that SC and BD are congruent by CPCT. Okay. So let us first prove that AOC and BOD are what? Congruent. So question number 3, first you see the diagram. That is the diagram. A, O, C, D, B. Okay. In the question it is given OA equals to OB. OA equals to OB. OA equals to OB. That means this side and this side are what? Equal. And OC equals to OD. OC, this side equals to OD, this side. Okay. And AOB equals to COD. AOB, that means this angle equals to what? COD. COD, that means this angle equals to what? This angle. This angle AOB equals to this angle. These two angles are equal. So let us first prove AOC and BOD as congruent. If these two triangles are congruent, then you can say that AC and BD will be what? Equal by CPCT. Okay. So first light from triangle AOC and BOD, triangle BOD, we have BOD, from triangle AOC and BOD we have what? OA equals to what? OA equals to what? OB. OA equals to OB. And OC equals to what? OD. OC equals to what? OD. They are given, okay? Given, okay? Both are given. And what? Angle angle AOB equals to angle AOB equals to angle COD. Okay, they are also equal. So AOB, this angle I can break into two parts, like AOC and COB. Okay, so write AOC plus angle what? COB. I can break AOB into two triangles. Okay, if I add these two triangles, then I'll get AOB. Like this, COD, I can break into two triangles, COB and BOD. COB and BOD. Okay, COB plus BOD. Okay, here you see COB and COB both in both sides they are present, so we can cancel them. Okay, we can cancel them and we can write what? AOC equals to what? BOD, angle BOD. That means what? AOC, that means what? This angle equals to what? BOD, that means what? This angle. So we can say that these two triangles are what? Congruent, because you see this side and this side are equal, this angle and this angle, this side and this side are equal, this side and this side are equal, this angle and this angle are equal. So we can say that what? They are what? Congruent. Okay, so we can write what? Therefore triangle AOC congruent to triangle BOD. Okay, how they are congruent? They are congruent by what? Two sides and one angle. Two sides and one angle. So SAS. Okay, they are congruent. Now we can say that SC equals to BD. How? By CPCT. Therefore SC equals to what? BD CPCT. Okay, as we said earlier, because the two triangles are equal, then the rest parts are also what? Congruence. If the two triangles are congruent, then the rest part are also what? Congruent. Now come to question number 4. Okay, now come to question number 4. You see question number 4, what is given? If AB equals to MN, okay, if AB equals to MN, you see the figure, okay, AB equals to MN, that means the two line segment, if AB and MN bisect each other, okay, that means AB and MN are two line segment and they bisect each other what? At O. If they bisect each other at O, then you can say that AO equals to BO, because they bisect each other, okay, at O. And AM and BN are perpendiculars. AM and BN are the perpendiculars drawn on. AM is drawn to what? XY, and BN is drawn to what? Again on XY, okay. That means they are two perpendiculars on XY. Okay, prove that triangle OAM and OBN are what? Congruent, and hence prove that AM equals to BN. Okay, so let us draw the figure first. Okay, that is XY line segment and that is AB. Okay, and that is what? AB. Okay, AB, and they intersect at what? At O. Okay, and okay, AM. Okay, AM perpendicular on XY and what? BN. And BN perpendicular BN. Okay, BN perpendicular what? XY. Okay, now we have to prove what? Okay, now let us check how to prove. So see the question number 4. Okay, so if I take this triangle AM, AOM and BON, Right, from triangle AOM and triangle BON. From triangle AOM and BON, I can write what? I can write AO equals to BO. Okay? AO equals to BO because they bisect each other. Okay? And OM equals to ON. Okay? Since what? AB and XY, AB and XY bisect each other at what? At O. Okay? At O. This is the reason. Okay? This is the reason. Now you can say that this angle AMO 90 degree, AMO equals to what? AMO equals to what? AMO equals to what? BNO. That means this angle BNO. Why? Because each 90 degree, because they are perpendicular, so they makes an angle 90 degree. Okay, then you see whenever we seen that two sides are equal and one angle is 90 degree, so we apply what? RHS. So we can say that what? Triangle, we have to prove what? OAM. So you change the name OAM. AM and OM is same. OAM and what? OBN. OPN. You can write because it is given the question OAM and OBM, so we change the name. Okay. So you can say that OAM congruent to OBN RHS. Okay. Now we have to prove what? AM equals to BN. AM equals to BN. So AM equals to BN because since the two triangles are equal, so their corresponding paths also are equal. Therefore, I can write therefore AM equals to what? BN. You write CPCT. Okay? CPCT. Okay? Now come to question number 5. You see question number 5. XYZ is bisected by YP. Okay? XYZ is a triangle. What to say is an angle. XYZ is an angle and it has been bisected by YP. That means what? The angle XYZ has been bisected equally. Bisect means what? YP bisect the single angle into two equal angles. Okay? That is, we can say XYP and ZYP are what? Also equal because they have been bisected by what? YP. Okay, now the next part. And MLN is perpendicular to YP. MLN is perpendicular to YP. Prove that LM equals to LN. Okay. So see the proof. First, draw the diagram. Okay. This will be 90 degree, this will be also 90 degree. Okay. Okay. Now we have to prove LM equals to LN. That means LM equals to LN. LN, we have to prove these two sides are equal. So let us take these two angles. these two triangles, MYL and NLY, these two triangles, if we can prove these two triangles, are congruent, so you can say that this side and this side will be what? Congruent by simplicity. So first we prove that these two triangles are what? Congruent. Okay, so write question number 5. Right, from triangle YML and YL or NYL, from triangle YML and triangle NYL, what you can write? You see, we can write YM equals to YN. Why? Because YP bisect what? You write since angle XYZ, since angle XYZ is bisected by what? YP. If YP bisect, okay, sorry, you don't write this one, let us change. We can say that these two triangles are equal. Yes, we can say that MYL equals to what? MYL equals to NYL. Yes, these two angles are equal. Now we can write since angle XYZ is bisected, XYZ is bisected by what? YP. Okay, since angle Z is bisected by YP. Okay, now we can write MLY equals to MLY, this, that means 90 degree, MLY 90 degree, and NLY, they are also what? Equal, because each 90 degree. Okay, you write the reason each 90 degree. These are the statements and these are the reasons. And YL is the common side. In triangle MOL and NOL, YL is the common side. So you can write YL equals to what? YL. You write in bracket common side. Okay, so these two triangles are what? Equal. How? ASA. So write two angles on one side. So you can write triangle YML congruent to triangle NYL. How? ASA. Angle, side. Angle. Okay. So since the two triangles are equal, then the corresponding side is also what? Equal. Therefore you can write ML or LM. Yes, LM equals to what? LN or LN. Okay, simplicity. Corresponding parts of congruent triangle. Okay, now come to question number 6. You see, in the question number 6, I think the question is incomplete. In the figure, PM equals to PN, PM perpendicular B and PN perpendicular AC. So nothing is written to prove. Okay, so you can add what to say, one line to make it a question. Okay, so you can add triangle APM, prove that triangle APN congruent triangle PAN. Okay, so you add this one after that you add, prove that in question number 6, okay, prove that triangle APM congruent triangle PAN, okay, prove that triangle APM congruent triangle PAN, and hence proved what? AM equals to AN, AM equals to AN, okay, AM equals to AN, okay. So see the question, how the diagram is drawn. This side and this side are equal, okay. Now we have to prove, okay. Now we have to prove what? Prove that APM this triangle and PAN this triangle, we have to prove these two triangles are what? Congruent, and after that we also prove AM equals to AN, AM equals to what? AN, okay. So first of all, as like earlier, now let us prove, okay. Write question number 6. You see question number 6, what is given? Right, from triangle APM and triangle PAN, we have what? We have PN equals to PM. It is given, okay. PM equals to PN, it is given, okay. And ANP, it is 90 degree, angle ANP equals to angle AMP, write each 90 degree, okay, each 90 degree. And we can say that AP is the common side, so write AP equals to what? AP, write common side, okay. AP equals to AP common side, so two sides and one angle, and one angle is what? 90 degrees, so we can say that they are congruent. So triangle, therefore triangle APM congruent triangle PAN by RHS, because one angle is what? 90 degree. So since both the triangles are congruent, so this side and this side will be what? Congruent. Therefore angle AM equals to AN, what? Typicity, okay, proved, okay. Now come to question number 7. In the figure, AD equals to BC and AD equals to AD parallel BC, prove that AB equals to what? DC. I have to prove AB equals to what? DC. So how to prove? You see, this answer can be written in one line, because here you see AD and BC are what? Equal, and AD and BC are what? Parallel. So if the two sides are parallel and two sides are equal, then obviously it's a what? Parallelogram, because we know that in a parallelogram the sides are equal and the sides are what? Parallel. So we can say that what? It's a parallelogram, and AC is the what? Diagonal, and we know that the diagonals of a parallelogram bisect the parallelogram into, or bisect the figure into two equal triangle, two congruent triangle. So directly we can say that ADC congruent to ABC, and after that you can say that AB equals to CD by CPCT. But it will be very easy. Okay, so let us prove in another way. Okay. So write question number 7. Okay, now you see the diagram is given. Question number 7. Okay, these two sides are what? Parallel, and these two sides are also what? Equal. Okay, and S is the diagonal. A, B, C, D. Okay, this side and this side are equal and they are what? Parallel. Okay, here you see, first you write given AD equals to what? BC. AD equals to BC. Okay, AD equals to BC, and AD parallel what? BC. Therefore ABCD is a parallelogram. Parallelogram, okay? Right, and AC is the diagonal. Okay, right, since diagonal of a parallelogram bisect, here you see, before that you write, since you write one line here, okay, right, construction. Okay, let me write again. Right, construction. Okay, construction, that means what? Extra one thing we need to draw to prove it. Okay, you see one diagonal is there, SC, so let us draw another diagonal BD. So construction, join BD as diagonal. Okay, BD as diagonal. Now write, since diagonal of a parallelogram bisect each other. Since diagonals of a parallelogram bisect each other. Okay, now let us draw a diagonal. Okay, bisect each other at O. Okay, you give a point at O. Okay, you draw this line as extra, okay, to prove it. Okay, so you see that the diagonals of a parallelogram bisect each other. That means we can say that AO equals to OC. Okay, like this, OB equals to OD. Okay, now what? Now you write, okay, now you see we have to prove AB equals to DC. Okay, after drawing the diagonal BD, you see 1, 2, 3, 4 triangles has been formed. Now we need what? AB equals to DC. We have to prove what? AB equals to DC. That means we have to take AOB triangle and COD triangle. Okay, and if we can prove that these two triangles are what? Congruent, then you can say that their sides also are what? Congruent. Okay. Now write from triangle AOB and COD and triangle COD, what you can write? You see, AO equals to what? AO equals to CO and AO equals to what? AO equals to what? CO. Yes, and OB equals to OD. Right? Since diagonals of a parallelogram bisect each other. Okay, bisect each other at O. Okay, you write this one. Okay, after that, two sides. Now we can say that COD, this angle and this angle will be what? Vertical opposite angle. So you can write what? Angle AOB equals to angle COD, and you can write reason what? Vertically opposite angle. You write vertically opposite angle. I am writing BOA, but you write fully. Okay, don't write BOA. Okay, just for understanding I have written vertical opposite angle. So you see two sides and one angle, so you can say that SAS. So therefore triangle AOB congruent to triangle COD. Okay, how? SAS. Okay, SS condition. Okay, now we can say that what? Now we can say that these two triangles, these sides are equal. Now you can say that AB equals to what? DC by CPCT. Okay, CPCT. So that is proved. Okay, proved. Now come to question number 8. Okay, you see question number 8 is very easy. Okay, the diagram is given like this. The diagram is given like this. Now we have to prove what? In the given figure, triangle ABC and DCB are right angles. That means they have one angle 90 degree. Triangle ABC, ABC having right angle at A and DBC having right angle at what? D. At A and D respectively. And AC equals to DB. That means AC this side and equals to DB. These sides are what? Equal. Prove that ABC triangle ABC congruent to triangle DCB. ABC congruent to triangle DCB. That means we have to prove that these two triangles are what? Congruent. So it's very easy. So see the proof. So here you see, right from triangle ABC, and triangle DBC, we have to prove what? DCB. You take the name from the question. Okay, ABC and DCB. Okay, what we can write? We have we have what? We have AC equals to BD, AC equals to DB, it is given, okay? AC equals to DB, it is given, okay? We have to prove what? AC equals to B, it is given, okay? And we have to prove AC equals to what? AC equals to DB, it is given or what? AC equals to, yes, AC equals to DB, it is given, you write given. That is the reason, and these are the statements. And BAC equals to what? CD or BDC. BDC, write each 90 degree. BAD, angle A 90 degree, and BDC, D equals to 90 degree, so each 90 degree. And here in both the case you will find BC as what? Common side. How? Let us break these two triangles like this, separate A, B, C, this triangle. Now DBC or DCB, okay? DCB. You see, in both the triangle we are getting what? This side BC and BC. So we can say that BC equals to what? BC what? Common side. Common side. So you see, the triangles are equal and having one angle 90 degrees. So we can say that therefore triangle ABC congruent triangle DCB, okay, RHS, okay. Now we can prove that yes, we have already proved ABC congruent triangle DCB, okay, proved. Question, you have to prove the two triangle, okay. So we have proved. So it is exercise 13B. Now come to exercise 13C, okay. The first question it is given, you come to exercise 13C. The first question is given, what will be the other angles of a right angled isosceles triangle, okay? What will be the other angles of a right angled isosceles triangle, okay? The first question is given like this: an isosceles triangle having one angle 90 degree, okay. Exercise 13C, okay. First question, this is a isosceles triangle, okay. This side and this side are equal, okay, and angle B measuring 90 degree. So the question is asked, what will be the measure of the other two angles, that means angle C and angle B. Obviously, if we know that the sum of the three angles of a triangle is what? 180 degree. So if it is 90 degree, then this two will be what? 90 degree. So these two angles will be what? Equal, because if these sides are equal, then their corresponding interior angles are what? Equal. So if the summation of these two angles is 90 degree, so each will be what? 45 degree. Okay. So each will be what? 45 degree. So write 45 degree and 45 degree. That will be the answer. Okay. Can you draw an obtuse angled isosceles triangle? Yes, we can draw an obtuse angle isosceles triangle. How? You see, if I draw this angle, okay, and if I say this side and these sides are equal, then I can draw an obtuse angle ABC, okay, having measuring angle 110 degree, okay. 110 degree is greater than 90 degree, so it's an obtuse angle triangle, and in which AB equals to what? BC. So we can draw an obtuse angle isosceles triangle. that is obtuse angle, isosceles triangle. So we can draw. Yes, we can draw. Okay, yes, we can draw. After that you draw this one like this. Okay, this side and this side are equal. Okay, and you join this side. Okay, so these two sides are equal. So A, B, C. Yes, we can draw here. Here you write here AB equals to AC and angle ABC equals to 110 degree. Okay, obtuse angle. Okay, up to this much you write. That is question number 2. Okay, sorry, 1B, 1A, this one 1B, 1B. Okay, now come to question number 2. The vertical angle of an isosceles triangle is 110 degree. What must be the size of each of its base triangle? Okay, the vertical angle of an isosceles triangle is what? 110 degree. That is vertical angle of an isosceles triangle. Suppose this is an isosceles triangle. Okay, this is an isosceles triangle. Okay, so if this is the vertical angle and measuring angle what? 110 degree ABC. Okay, then the question is asked what will be the measure of the other two angles. So obviously we know the sum of the three angles of a triangle is what? 180 degree. Okay, so if I subtract from 180, if I subtract angle A, then I will find measure of angle B and C, because AB and AC are what? Equal, isosceles triangle. Then angle B and angle C will be what? Equal. So I can find what? So now let us subtract 180 degree minus 110 degree. Okay, let us write. You draw the diagram first. Okay, like this. Then you write, since AB equals to AC. Okay, that means since ABC is an isosceles triangle, so write like this: since triangle ABC is an isosceles triangle, therefore AB equals to AC and angle B equals to angle C. Write isosceles property. Isosceles property of triangle. Angle B equals to angle C, isosceles property of triangle. Now we can find, you see, now by angle sum property of triangle, we can write what? Angle A plus angle B plus angle C equals to what? 180 degree. Since we know angle A and angle B are what? Equal. Okay, so angle A plus angle B and C are equal, so I can write angle B plus angle B equals to what? 180 degree. Now I can write what? Angle A plus angle 2B equals to what? 180 degree. Okay, now I can write in place of angle A, we write given angle A equals to what? 110 degree. Okay, so I can write angle in place of angle A, I can write 110 degree. Angle B, okay, equals to what? 180 degree. Now we can find what? 2B equals to 180 degree minus 110 degree. Okay, 2B equals to 180 degree minus 110 degree. Okay, after that you come here. Okay, then I can write what? 180 degree minus 110 degree, what? 70 degree. So I can write 2 angle B equals to 70 degree. So angle B equals to what? Angle B equals to 70 degree by 2. That means what? I can write angle B equals to what? 35 degree. Okay, if angle B equals to 35 degree, then angle C will be what? 35 degree. That is the answer. Therefore, angle B equals to 35 degree and angle C will be what? 35 degree. Since the two triangles are what? Equal. What must be the size of its base angles? So write, base angles are what? Angle B and angle C. So write angle B equals to 35 degree and angle C equals to 35 degree. These are the base angle. Okay. Now come to question number B. What is the size of each exterior angle of an equilateral triangle? Okay. This is an equilateral triangle. Okay. That means in equilateral triangle, the measure of all angles are what? Equal. So we know that the measure of three angles of a triangle is 180 degree. So each will be what? 60 degree. 60 degree. This will be what? 60 degree. Each will be what? 60 degree. And we know that what is the size of each exterior angle of an equilateral triangle? The size of each exterior angle of an equilateral triangle will be what? It will be like this. This is 2B we have done, okay? 2A we have done. Now we are doing 2B, okay? 2B, okay? So here you see, suppose this is a isosceles triangle, okay, A, B, C, and here suppose D is the exterior angle, okay, and we know that this side and this side are equal because it is said in the question. It's an equilateral triangle, and in equilateral triangle all the angles will be what? Also equal. We know that the sum of the three angles of a triangle is what? 180 degree. So each will be 60 plus 60 plus 60, because 60 plus 60 plus 60 equals to what? 180 degree. So angle A will be 60 degree, angle B will be 60 degree, angle C will be what? 60 degree. So exterior angle, we know that exterior angle equals to the sum of the two interior opposite angles. The sum of the two interior opposite angles. So we can write, since it is an equilateral triangle, since it is an equilateral triangle, so all the measures of three angles will be equal. That is, angle A equals to angle B equals to angle C equals to what? Each 60 degree, okay? 60 degree. Now by exterior angle property, we can write what? Exterior angle property, that means what? Exterior angle equals to the sum of the two opposite interior angles. Okay? So here exterior angle ACD. So ACD will be what? Angle A plus angle B. These are the two opposite interior angles. So angle A is what? 60 degree, and angle B is also what? 60 degree. So 60 plus 60, 120 degree. So that is the answer. Okay. What is the size of each exterior angle of an equilateral angle? So it will be what? 120 degree. Okay. Now come to question number 3. You see question number 3, what is given? ABC is an isosceles triangle with what? AB equals to what? With AB equals to with A equals to B equals to 50 degree. Name the pair of sides of which are equal. Okay. You see question number 3. Now we have done question number 2B. Now question number 3. You see, question number 3 will be like this. In triangle ABC, with side AB equals to AC. Suppose this is a triangle, okay? Suppose this is a triangle, okay? ABC. A, B, C, okay? And it is given in the question that AB equals to AC. That means this side and this side are equal. And angle A equals to what? Angle A equals to what? 80 degree. So what will be the measure of angle B? So from the isosceles property of a triangle, you can say that if the two sides are equal, then their opposite angles are also, then their opposite angles are what? Equal. That means angle B and angle C will be equal. So we know that the sum of the three angles of a triangle is what? 180 degree. So if one angle is 80 degree, then the other two will be what? 100 degree. Since B and C are equal, so each will be what? 50 degree. So we can write directly, you can write like this, okay? Number 3, you can write each, what is the measure of angle B? So write, you can write like this. Since it is an isosceles triangle, therefore AB equals to AC, okay? And angle B will be equals to angle C, as like earlier. Angle B will be equals to what? Angle C, okay? Angle B will be equals to what? Angle C, okay? Now you can write, now by angle sum property of triangle, angle sum property of triangle, I can write angle A plus angle B plus angle C equals to what? 180 degree. So in place of angle A, I can write 80 degree plus in angle B, and in case of angle C, I can write angle B because they are equal, 180 degree, okay? So 80 degree plus 2 angle B equals to 180 degree, because if I add, then it will become 2 angle B. So I can write 2 angle B equals to 180 degree minus 80 degree, okay? So I can write 2 angle B equals to what? 100 degree, okay? After that you come here, okay? So you can write angle B equals to what? 100 degree by what? 2. As we cancel, then we get 50 degree. That means what? Therefore angle B equals to what? 50 degree. That is the answer. Angle B equals to what? 50 degree. Now come to question number 4. In triangle ABC, angle A and angle B equals to 50 degree. Name the pair of sides which are equal, okay? That means in question number 4 it is given like this, okay? It is given like this. Angle A and angle B, this is an isosceles triangle, okay? Angle A and angle B are equal, okay? Having measuring angle what? 50 degree, okay? Now we have to name the pair of sides which are equal. So if these two angles are equal, then their opposite sides are equal. That means AC and BC. So you can write in question number 8, name the pair of sides which are equal. So I can write what? In question number 8 I can write, question number 4 I can write AC equals to what? BC, okay? To draw the diagram, okay? AC equals to BC, okay? Now come to question number 5. Okay, Come to question number 5. You see question number 5, the diagram is drawn. Okay, we have to prove in triangle ABC, in triangle in the given figure below, AN equals to AC and BAC equals to 52 degree, ACK equals to 84 degree, and BCK is a straight line. Prove that NB equals to NC. Okay, now first let us draw the diagram. Okay, question number 5. You see the diagram first. Okay, we can find this in two ways. Okay, we have to say that Bn equals to what? Nb equals to Nc, Nb equals to Nb equals to Nc. That means these two sides we have to prove what? Equal. If you want to prove these two sides are equal, then you have to prove that angle B and angle C are equal. Okay, we have to prove Nb equals to Nc. Okay, now see this question number 5. Okay, question number 5, you see, first you will write, first you check this one. Okay, now we have to find what? Angle C. Okay, let us find angle measure of angle C. Okay, so how to find measure of angle C? Okay, I can write angle C equals to what? Here one thing you do, here you see, first you take this one as exterior angle. Okay, you leave about this triangle, you leave about this triangle. If you thought about this triangle, okay, ANC, then 52 degree. Okay, 52 degree. Okay, one angle A equals to 52 degree, and angle N we don't know, angle this angle also we don't know, so we can apply here. And it is given in the question, said that AN equals to AC, AN and AC are what? Equal. Then this angle and this angle will be what? Equal. You leave about this angle. Okay, you leave about this angle, you just thought about or think about this angle. It is given a question that this side and this side are equal. So if this side and this side are equal, then the opposite angle, this angle and this angle. So you can say that this angle and this angle are what? Equal. So write, since AN equals to what? AC, therefore triangle ANC is an isosceles triangle. Hence, or you can write, and angle N equals to angle C. Right here, by isosceles ISO, I am writing a short form, isosceles property of triangle. Okay, by isosceles property of triangle. Now we can find this angle. Okay, we know that what? The sum of the exterior angle equals to the sum of the two opposite interior angles. So right now, by exterior angle property Now by exterior angle property I can write here exterior angle what? AC, here it is given what? ACK, that is K, okay. So I can write angle ACK is the exterior angle, and we know exterior angle equals to what? The sum of the two interior angles. If you leave about this triangle, then two interior angles are what? Angle A and angle C. Angle A and angle what? C. Angle A and angle N. So I can write angle A plus angle N, okay, angle N, or I can write angle ANC plus angle ACN, okay. So I can find here what? SCK is what? 84 degree given. From here ANC we don't know, so we'll keep it as. So here will be ANC and CAN. These are the two opposite interior angles, okay. CAN. So ANC we do know, ANC, okay, we don't know, we'll keep it, and ACAN I can write what? 52 degree, okay, 52 degree. Now we can find what? ANC equals to what? 84 degree minus 52 degree, okay. If I subtract, then ANC equals to what? If I take this one to the right side, left side, then it will become what? Minus, and will remain ANC. So I wrote ANC directly, 84 minus 52 degree. So I can write ANC equals to what? 84 minus 52, 4 minus 2, 2, okay, 5 minus 8 minus 5, 3, so 32 degree, okay. So 32 degree, this angle is what? 32 degree. Now you can find this portion, okay, because BCK is a straight line. So write, now you write, since BCK is a straight line, then I can write what? BCK is a straight line, then I can write what? I can write BCK as like this, BC or NCB. I can write NCB, that means this angle NCB, this angle plus this angle what? ACN. ANC equals to 32 degree, then therefore ACN will be what? 32 degree. Why? Because these two are what? Equal, right? Since ANC equals to angle ACN, they are equal, okay. So NCB, angle NCB plus angle ACN plus ACK equals to what? 180 degree, okay. So write the reason here, linear pair, because it's a straight line, so this three will be what? Linear angles, okay. So I can write NCB, I don't know, so I'll keep NCB plus ACN what? 32 degree plus ACK what? ACK 84 degree equals to what? 180 degree, okay. So now I can find NCB plus 4 plus 2, 6, 8 plus 3, okay, 116, okay. Goes to what? 180 degree. Now you see angle NCB will be what? 180 degree minus 116 degree. Okay, so 180. Okay, -180 minus 116 degree. Okay, so 10 minus 6 4. Okay, and here remains 7. 7 minus 1 what? 6. 64 degree. Okay, 64 degree. I can write what? 64 degree. Okay, now let us find angle B. So again I can write like this. Right, again if I take ABC as one triangle, then SEK will be again what? SEK will be what? Now you leave about NC. If you leave NC, then ABC is a triangle and SEK will be its what? SEK will be what? Its interior. Okay, what to say? Exterior angle. So again from triangle ABC I can write ACK, angle ACK equals to angle ABC plus angle BAC. Okay, so I can write ABC, I don't know, and BAC I can write what? BAC I can write 52 degree. Okay, and SEK equals to what? So NCB, okay, if you want to prove NB equals to NC, then we can prove like this. If this is 32, then 84 plus 32 from 180 degree, 84 plus 34, 84 plus 32, 6, 116 degree. Okay, yes, NCB what we got? 16 degree. Now we have to find what? Angle BAC equals to what? 52 degree. Okay, so we can find angle SEK. So let us check what we can find. ABC will be what? 84 degree minus 52 degree. We are getting what? 84 minus 52. We are getting 4 minus 2 2, 8 minus 5 3, 32 degree. We are getting this one. ABC equals to 32 degree. So what we have done here? Angle NCB. Angle NCB I can write like this. ANC. Okay, first portion, okay, you do like this. Okay, it will not batch. You write this one again. You write this one. You don't take the exterior angle. Okay, let us do in another way. Okay, now you have to find what? This angle. Okay, so these two sides are equal, so this angle and this angle will be equal. So I can write what? Question number 5. Since AB equals to what? SE, therefore angle ABC AA, since AN, yes, since AN equals to SE, so I can write ANC is an isosceles triangle. Isosceles triangle. So I can write in isosceles triangle, the two triangles will be what? Equal. So I can write what? Therefore angle ANC plus angle ACN plus angle NAC equals to what? 180 degree. Okay. So ANC plus isosceles property of triangle. Okay, ANC plus SCN. Okay, ANC and SCN will be what? Equal, because since SN equals to AC, so this angle and this angle will be equal. So we can write in place of ANC, SCN, I can write what? ANC, because they are equal. ANC plus angle NA, in place of NAC I can write what? 52 degree equals to what? 180 degree. Now let us do in that way. Okay, 52 degree. Okay, now you see here will be 2ANC plus 52 degree equals to what? 180 degree. Okay, now we can find what? 2ANC equals to what? 180 degree minus 52 degree. Okay, now we can find what? 2ANC equals to what? 180 degree 52 degree. Okay, and 10 minus 2 what? 8. 10 minus 2 what? 8. Okay, here remain what? 7 minus 5 2. We are getting what? 28 degree. Okay, we are getting what? 28 degree. $180. Okay, yes, and here remain what? 1. Here remain what? 1. So we are getting 128 degree. Now we can say angle ANC equals to what? 128 divided by 2. Here 2 remain. So if I cancel, then 6 2 jar 12, 6 4 jar 6 2 jar 12 and 2 4 jar 8, 64 degree. So I can write what? Angle ANC equals to what? 64 degree. If angle ANC, this angle is 64, obviously this angle will be what also? 64. So write therefore angle ACN equals to what? 64 degree. Okay, now we can find this angle. Right, since BCK is a straight line. Okay, BCK is a straight line, therefore you can write what? NCB, angle NCB plus angle ACN plus angle ACK equals to what? 180 degree. Okay, you write linear pair as like earlier. Okay, I have written linear pair. Okay, linear pair. Now NCB we don't know. NCB we don't know. We'll keep NCB plus ACN we know what? 64 degree plus ACK 84 degree equals to what? 180 degree. So I can find NCB. So NCB will be what? If I add, then 4 plus 4 8 and 6 plus 4 148 degree. Okay, equals to what? 180 degree. Okay, 180 degree. Now I can find angle NCB. Angle NCB will be what? Equals to what? 180 degree minus 148 degree. Okay, so I can write angle NCB equals to what? 2 Okay, 10 minus 8 2, here remain what? 7, 7 minus 4 3, 1 minus 1 0, 32 degree. That means we are getting NCB, that means this what? 32 degree. Okay, and if angle what? NBC equals to what? 32 degrees. So you can say that BN equals to NB equals to NC. Now let us find this one. Okay, so as like earlier, write again, from triangle ABC, from triangle ABC we can write what? ACK, exterior angle ACK, ACK equals to angle BAC plus BAC plus angle BAC plus angle ABC, angle ABC. Okay, okay, so SCK is what given? Right, SCK is given what? SCK is 84 degree, so we'll write 84 degree equals to what? BAC, BAC what? 52 degree, 52 degree plus ABC you don't know, so I can write what? Angle ABC equals to what? 84 degree minus 52 degree, that is 4 minus 2 2, okay, and 8 minus 5 3, that means what? ABC, ABC mainly which angle? This angle, angle B 32 degree we are getting, and NCB 32 degree. Just we have found NCB equals to what? 32 degree. You see NCB 32 degree, that means angle C, and what? ABC, ABC we are getting what? 32 degree. Okay, ABC that means mainly angle B, and NCB that means mainly angle C, that means both are equal, so we can say that BN equals to NB equals to NC. Okay, so now we can say that NB equals to what? NC. Right, since angle B equals to angle C, therefore NB equals to what? NC. Isosceles property of triangle. Okay, now come to question number 6. In triangle, in the figure AB equals to AC, prove that BD equals to BC. Okay, we have to prove that BD equals to what? We have to prove what? We have to prove BD equals to what? BC. Okay, okay, so check how to find number 6. Okay, you see question number 6, it is given like this. Okay, so you can find like this. Okay, question number 6. Okay, we have to prove what? BD equals to BC, BD equals to BC, that means what? If BD equals to BC, that means we have to prove this angle and this angle are what? Equal. Okay, so let us find what? Angle B. So write how to find angle B. You can find angle B like this. Since AB equals to AC, so this angle and this angle and this angle will be what? Equal. So write, since AB equals to AC, therefore ABC is a isosceles triangle. Okay, isosceles triangle. So I can write what? Angle B equals to angle C. Now let us find angle B and angle C. Okay, therefore now by angle sum property. Angle sum property, I can write what? Angle A plus angle B plus angle C equals to what? 180 degree. Okay. Then I can write angle A equals to what? 40 degree. Angle B and angle C I can write what? Equal. So I can write angle B equals to plus angle B. In place of angle C I can write again what? Angle B. Because why? Do you know? Angle B and angle C are equal. So in place of angle C I can write angle B equals to what? 180 degree. Now I can find 40 degree plus 2 angle B equals to what? 180 degree. Now I can write what? Angle B equals to what? 180 degree minus 40 degree. That means what? Angle B equals to what? 2 angle B equals to what? 2 angle B equals to 180 minus 40 degree equals to what? 0, 4, 1, 140 degree. Okay. So now I can write what? Implies angle B equals to what? 140 degree divided by 2 equals to what? 70 degree. That means angle B we are getting what? 70 degree. Okay. Here you see one thing. ABD is 30 degree. And if the whole angle is 70 degree, then this part will be what? This part will be what? This part will be what? Obviously 40 degree. Because the whole angle is 70 degree you got. So this part will be obviously 40 degree. Because here it is 30 and so this angle plus this angle equals to what? Angle B. So if this one is 30 degree, so this will be obviously 40 degree. Okay. So write. After that you write. Right, angle B equals to, I can write what? Angle ABD plus angle DBC. Okay. So from here I can write angle B was 70 degree. So ABD 30 degree plus angle DBC I can find. So I can write angle DBC will be what? 70 degree minus 30 degree. That means what? 40 degree. DBC equals to what? 40 degree. So we found angle DBC. That means we found this angle. Okay. 40 degree. Okay. Now you have to find what? This angle. This angle we have already found what? 70 degree. So you can write therefore angle C equals to what? 70 degree. Because these two angles are equal. So angle C, what we got? 70 degree. So this angle what we got? 40 degree. Now you can find this angle. Okay, right. Again from triangle BDC I can write what? Angle B. Now we are taking this one. Angle DBC plus angle BCD plus BCD plus angle BDC equals to what? 180 degree. You write here angle sum property. Angle sum property. Okay, I am writing in short form. You write fully. ACP I have written. You don't write ACP. You write fully angle sum property. Okay. So DBC what? DBC what? 40 degree plus BCD what? 70 degree plus BDC we have to find 180 degree. Okay. So we can write what? Angle BDC equals to what? Angle BDC, if I add then 70 plus 40, 110 degree equals to what? 180 degree. So I can write what? Angle BDC equals to what? 180 degree minus 110 degree. Okay. So I can write what? Angle BDC equals to what? 110 degree minus 170 degree. That means what? BDC, that means this angle we are getting what? 70 degree. And this angle in the first portion we have got what? 70 degree. Angle C here 70 degree. Okay. So these two triangles are equal. That means this side and this side will be what? Equal. So write. After that you write. Again you write. Since angle BDC equals to what? Angle BCD. therefore BD equals to BC. BD equals to what? BD equals to what? BC. Isosceles property of triangle. Okay, isosceles property of triangle. Okay, so that is question number 6. Now the last question, that is question number 9. Okay, in the last question it is given, you see there is no diagram. ABCD is a straight line with AB equals to BC equals to CD. P is a point or not lying on a straight line such that PB equals to PC. So you see like this, ABCD is a straight line. Okay, A B C D. Okay, this is a what? Straight line. Okay, this is a straight line, and P is the point which is not lying on ABC on the straight line, and here AB equals to BC equals to 0. That means these are same. So from here if I add like this the diagram will be. Okay, now we have to prove what? And PB equals to PC. Here PB equals to PC. That means this side and this side are equal. This side and this side are equal. So we have to prove what? PA equals to PD. PA equals to what? PD. Okay, so see how to prove. It's the last question. Now we have to prove PA equals to what? PD. Okay, so write given let us take this triangle. Okay, you write from triangle PBA, okay, and triangle PCD. What you can write? PB equals to PC, it is given. PB equals to what? PC, it is given. Okay, and AB equals to CD, we can write AB equals to CD, they are given. Okay, it is given, and PBA, angle PBA will be equals to angle PCD. Since because if these two sides are equal, then these two angles will be equal. So if these two angles are equal, then these two angles will be what? Equal. Okay, since you can write PB equals to PC, hence PBC equals to PCB. Okay, isosceles property. Okay, so here you see 1 2 3, we have got 3 corresponding parts are equal, so the triangle will be what? Equal. Therefore PBA and PCD, triangle PBA and PCD are what? Congruent. What? Congruent. By how? AS, side angle side, 2 sides and 1 angle. So we can say that their corresponding sides also are equal, because if I take PBA and PCB, then PA and PB are the rest corresponding sides. So therefore I can write PA equals to what? PD. You write simplicity. Okay, you write here simplicity, and hence proved right. Okay, so this is the end of the chapter, that is chapter number 13, and also the end of the second evaluation course. Okay, you practice at your home more and more, then you can score a good mark. Okay, and if you find any problem regarding any questions of the second evaluation course from any chapter, then without hesitation you call me, I shall help you. Okay, thank you very much.